So we're going to go through the example series circuit that we went through in class. And you can watch this video if you just want a refresher or if you forgot the example that we went and the steps that we had to take to get our answers. So you can see we're looking at this circuit that has three different resistors. Resistor 1 is 220 ohms of resistance, resistor 2 has 470, and resistor 3 has 1.2 kilo ohms, which is also 1200 ohms because kilo means times 1,000. And we know that our battery is giving us 12 volts of voltage. So we want to find a couple things. First, we want to find our total resistance. So this is easy to do in a series circuit because in a series, all we have to do is add the three resistances that we have. So we have 220, 470, and 1.2 kilo ohms. So we can put those into our equation, and our total resistance is going to equal 220 plus 470 plus 1.2 kilo ohms, and make sure that when you add this, you change this to 1200. So now my total resistance is going to end up being 1890 ohms or 1.89 kilo ohms. So now we want to know the current through each of these resistors. So the thing that we can do first is find the total current, which we can use our equation, which is V equals IR, and once we solve it for current, we get the total I is equal to the total T over the total R. So we know that our total voltage is the voltage that the battery is providing, 12 volts, and our total resistance is what we just got, 1.89 kilo ohms or 1890 ohms. So when we plug that in, 12 volts over 1890 ohms, we get 0.063 amps, or we can change that to 6.3 milliamps. And we know that in a series circuit, every single one of these resistors gets the same amount of current. So we can say that the total current is equal to the current through resistor 1, current through resistor 2, and current through resistor 3. So all of them have a current of 6.3 milliamps or 0.063 amps. Now we want to know what is the voltage going through each of these resistors, because we know that in a series circuit they each get a little bit of the voltage. So to get the first one, we're going to take the voltage, we're going to try to get the voltage through number 1, and we're going to multiply the resistance through number 1 times the current through number 1. And that's Ohm's law, which we talked about in class. So when we plug those in, voltage through 1 is 0.063 amps, which is the current, which we found is the current for all of them, times what the resistance is of that resistor, 220, and we get our voltage to be 1.4 volts going through resistor 1. Do the exact same thing for the second one, so we get 0.063 amps, the same current, times that voltage, 470 ohms, and we get a voltage of 2.98. And our third one, we do the same thing, and now our resistance is 1200 ohms. So our voltage comes out to be 7.6 volts. So you can tell that the greater the resistance, the more voltage it takes to get through the resistor. And the last thing we want to do is verify our answers using Kirchhoff's voltage law, which states that each voltage needs to add up to equal the total voltage. So we know that 12 volts is what's being provided by the battery. This is the voltage going through each of them, 1.4 through number 1, 2.98 going through number 2, and 7.6 volts going through number 3. And that comes out to be 12 volts equals 11.9 volts. And the reason that these numbers are not exact is because we've rounded each of these voltages.